Variational autoencoders are powerful generative models that can learn the underlying structure of data and generate new samples. In this video, we will introduce you to the basics of variational autoencoder and will guide you through implementing a simple variational autoencoder in Python using popular deep learning framework. So let's get started with understanding what is a variational autoencoder. Basically, a variational autoencoder is a type of neural network used for generative modeling. It is the variation of the classic autoencoder which learns to reconstruct its input data. The main difference is that the variational autoencoder uses a probabilistic approach to generate new data. A standard autoencoder consists of an encoder and decoder, where the encoder maps the input data to lower dimensional latent space, while decoder maps the latent space back to the original data space. And the goal of autoencoder is to learn the representation of data that can be reconstructed as accurately as possible. Now comes the variational autoencoder. Now the encoder of this variational autoencoder maps the input data to a probability distribution over the latent space. So instead of a fixed length vector, the latent space is represented as a continuous distribution, such as Gaussian distribution. And this distribution encodes the probability of each possible latent vector. Now the variational autoencoder's decoder part will then generate a new sample from this distribution and maps it back to the original data space. The main advantage of the variational autoencoder is that it can generate new data points that are similar to the training data. And this makes it useful for tasks such as image and text generation, where the goal is to create new samples that follow the same pattern as the training data. So to summarize this, we can say variational autoencoder is a neural network that uses a probabilistic approach to generate new data by learning a latent space representation of the input data. So let's understand it better using a Python code. So here is a simple example of implementing a variational autoencoder using keras and TensorFlow, and this code can work equally well on the Google Colab. So first of all, you will install the TensorFlow and keras. So in the first cell of your Colab notebook, you will install the TensorFlow and keras using these commands. Then you will load the MNIST dataset using this tensorflows.keras.dataset. Then you will define the variational autoencoder architecture, where you will use a simply fully connected layer with a latent space of 10 dimensions, and then you will compile the variational autoencoder. So where you will define the binary cross entropy loss and the Adam optimizer, and this loss function consists of two parts: the binary cross entropy loss for reconstructing the input images and a regularizer that encourages the latent space representation to be distributed according to a standard Gaussian distribution. And then you will train the variational autoencoder, and after that you will generate new images from this learned latent space. And finally, you can visualize this generated images using matplotlib. So this code will display 10 generated images. Note that this is a simple example, and there are many ways to improve the variational autoencoder performance, such as experimenting with different network architectures, increasing the number of epochs, or using batch normalizations. Additionally, you can also use other data sets such as CIFAR10 to train the variational autoencoder and observe its performance on more complex images. Thank you.